Hi, my name is Chibuzo Mongba, and this is my EEL2161 final project. So the agenda of this presentation is going to be the overview, the background of the project, like the C program implementation. Uh, we'll see the code in action after I've explained how to implement the program with C, and then takeaways and feedback for the project, which I personally have after working on this project assigned to us. So the introduction is that for the introduction, the final project of the EEL2161 section 002 was centered around creating a C program to solve second order differential equations based on initial conditions and coefficients. So it was mainly just an application of C programming to solve some math problems. The background of the project was that students were required to create a C program to find the zero input response of a time invariant system. It was based on second order differential equations, um, knowledge of quadratic equations with real roots and complex roots is required for the project. The formula for computing zero input response time was provided. Non-trivial solutions need be found. Constants of the response time are found using the non-trivial roots and initial conditions. Constants can be calculated in three ways, which is the important part because you have to determine what type of non-trivial roots you get, and that will determine how the constants will be calculated. So in this next slide, you'll see three formulas that itemize how you should represent the response time at the end after you've calculated the coefficients. So basically, like I said in the previous slide, you have to apply the roots and the initial conditions. So the roots are the lambda 1 and lambda 2. Those are the non-trivial roots. So for repeating, that means they're equal. For non-repeating, they are not equal. So use the first formula and then use the second formula and then the third formula. So the project also required us to find the C's and also find the theta and display the response time, the YT function on our screen. So for the mathematical implementation, I had to make use of the quadratic formula to calculate the real roots of the quadratic equation, which was like the non-trivial root. So I just did the quadratic formula, which was minus b plus or minus square root of b squared minus 4ac over 2a. So one root is for the plus side and the other root is for the minus side. And then also for the complex roots, which are alpha and beta, the real part, which was minus b over 2a, which is just splitting the quadratic formula into two, just splitting it up. And then the other side, I would have done b squared minus 4ac, but I know that it is complex because what's under the square root is less than zero. So therefore, I had to multiply it by minus one. So I flipped the other. So instead, I had 4ac minus b squared, and that is what I used to calculate beta. And when if I was to represent the conjugate, I'll have to add I to the side because it's multiplied by a square root of minus one. So and I consider that at zero input response, t tends towards zero, right? So if you consider that, going back to the previous formula, you see that if we make t equals to zero, everything here, like this becomes e raised to power zero, and this becomes e raised to power zero, so which is one. So you see that the response time is equals to c1 plus c2. So that's for yt when you're considering the zeroth derivative, which is the function itself. So use the initial condition there to get c1 plus c2 equals something, which is the initial condition. Then for the second step, you have to use the differential. So you have to differentiate the function to get the y prime of t, which you then apply the initial conditions to and use to calculate C1 and C2. So in that case, I think you have like lambda 1 times C1 times e raised to power lambda 1 t and so on and so forth. So in the end, you still have C1 and C2 equals to something, just that they'll have coefficients this time. And then you can solve it simultaneously using simultaneous equations. So for the non-repeated roots, I ended up using the two variable simultaneous equation formula for C1 and C2. And then for the repeated roots, you have to consider at t at zero response time, t tends to zero. So you see that initial at first you see that C1 is already equals to the first initial because if you raise anything to the power of if you multiply C2 by zero, C2 goes away. So you see that C1 is equals to the response time. And then for complex conjugates, you just have to simplify it a bit more. I may not be able to explain everything here, but um, I think the formulas here are kind of slightly off because I used the formulas in our teacher's YouTube video explanation. So those ones are more correct. I think only this formula was correct, the first formula. Moving on to the next slide. Um, the C implementation of the program. The C implementation of the program, I provided this the pseudocode first of all because not everyone watching this video might be a skilled C programmer, so they may not understand everything that's going on in the program eventually here. So we start from the pseudocode and look at this. Um, you have a function here, the computations function, the root function, and the main function. So most important thing you need to know here is that these two functions are helping the main function to work, and the main function is dependent on them and getting values from them to work. So you declare your variables, you set your variables, you open a text file, um, you read from the text file, then you loop through the lines because within the text file, unfortunately, I don't have a picture of the text file. Within the text file, you see that there are values. There are values that represent the values that should have been imputed by the user. So instead of the user imputing those values, the program using the right C language, you know that it has to read each line and then capture the variables and store them as four float values, as I wrote here. So this is just the formatting the text had. This formatting was 10 space justification. So to make sure that it's aligned up like in a table. So and then if a squared is equal to 4 times. So this is just to check if you have either repeating or non-repeating roots, which means it should be real roots. This is check if it's real roots. And if it's real roots, you'll be able to use quadratic formula. And otherwise, which is else, you should see that it's a complex root, and then you should calculate alpha and beta. But the end of the real root part, which is the real root if, was that you run the root nature function. The root nature function takes in inputs R1, R2, um, and to determine if the roots are repeating or not repeating. If they're repeating, then the roots should be equal to each other. And if they're not repeating, then they're not equal. So that's the only work the root nature function has to do, right? And then once it finds that out, so it's a helping function, just like a helper. Once it's done, it passes it back to the main function, which is doing the main job of controlling all the processes. So it's just like there are other devices in a big computer, and then the main function is like the brain of the operation, the head of the operation. So for the first one, unfortunately, I skipped this one. This one is basically like the last one, but the difference is that the user actually imputes the values instead of reading from the file. So in this case, you have to prompt the user. So this is the major difference. You prompting the user for the coefficients, and then you store those coefficients, and also prompt user for the initial conditions, store those initial conditions, and use them for the calculations. So the computations function, just the major calculations. So I think the final output of the project was supposed to be the response time. So that's the function of the competition function. Maybe I should have called it the response time function because it provides the response time which we want. That's basically that. And then to see the code in action, here it is. This is basically the code running. This is just syntax. You may not understand everything going on here, but I assure you that it's the same logic that was explained in the pseudocode. So if you still want to look at this, sure, you're free to do so. You can pause the video. So the major takeaways here, for me, was that from a student perspective, I gained my first experience solving differential equations, which I had never learned before. I learned a lot about string formatting and file management. I learned a way for to compute the values of alpha and beta for complex conjugates for quadratic equations, which I wasn't very familiar with because I only used to using the quadratic formula, but I had to think of another way to find like the coefficient of I when you're dealing with a complex conjugate. The feedback I have for this project was that it was a very good experience working on this project. It fit very well into my schedule, helped me better prepare for the final exam. I think it was a very good pick by our professor because it combines concepts from other electrical engineering core classes that makes learning more interconnected. And I look forward to more projects that build upon the knowledge I gained here. Uh, Thank you very much for listening. And thank you for my professor for giving me this opportunity to practice the skills. Thank you.